All right, I'm going to try to explain this using my new drawing tool, so it'll probably be a disaster, but let's see if we can do it. All right, so step one, you got to balance the equation. N2 plus H2 gives you ammonia NH3. Well, there's three H's over here, three hydrogens, only two over here, two nitrogens over here, only one over here, so we got to balance it. So let's go ahead and balance this. We're going to go N2 plus, we have two hydrogens and three hydrogens. To balance this out, 3 times 2 is 6. So let's go 3 H2 gives us, going to give us 6 hydrogens. And then here, we're going to put 2 NH3. Because now 2 times 3 gives us 6 hydrogens. 3 times 2 gives us 6 hydrogens. Over here, the 2 times the N gives us 2 nitrogens. And right here, you can see we have 2 nitrogens. All right, so now let's try to do these conversions with my new writing pad. Let's see if it's going to work. Where's my, okay, so remember, first step, we're going to go from grams to moles. So it's telling us we have 14 grams of nitrogen. You can see right here, N2 nitrogen gas is 28 grams per mole. And we're going to convert that into ammonia, NH3, which is 17 grams per mole. So right now, we're going to convert grams to moles, line times line. All right, so we want moles. So moles go on top. 1 mole, it's going to be really hard to write this, of N2 is 28 grams. And the problem right here tells us we got 14 grams. So I'm going to do it the method where you just get everything in one swoop. All right, so when we do this, we're going to get how many moles of nitrogen gas we got. But if you want to do it all in one, you could do that math. It's going to be 14 divided by 28. It's going to give you 0.5. But you can keep going. So now we're going to try to do this in one fell swoop. Now you look at the mole ratio. You can see, since there's no number in front of the N2, that means 1. 1 mole of nitrogen gas going to react with 2 moles of hydrogen gas to make 2 moles of ammonia. So the ratio is 2 to 1. But what goes on top, the 1 or the 2? Well, what we want is ammonia. We don't want nitrogen anymore. So the N2 is going to go on the bottom. So you can see there's a 1 in front of the N2. So it's 1 mole of N2. I'm not going to write mole because it's too hard. We'll give you 2 moles of ammonia, NH3. All right, when we do this, now it's going to convert the moles of nitrogen gas into moles of ammonia. Now we just got to do one more step. Now we got to convert the moles back into grams. So we want grams. We do not want moles anymore. So right here, it's going to be 1 mole, since I want to get rid of moles. And 1 mole of ammonia is 17 grams. So I go 17 grams. I probably should have my calculator ready, which I do not. So let's just do the math now. All right, so the top, you multiply all the top. 14 times 1 is 14. 14 times 2 is 28. 28 times 17. Let's see what that is. 28 times 17 equals 476. All right, so that goes on top. And what are we going to divide it by? 28 times 1 is 28 times 1 is 28. So it's 476 divided by 28. And let's see what we get here. 476 divided by 28 equals 17. We're going to get 17 grams of ammonia, NH3. All right, there's one of them. All right, this drawing tool is driving me crazy. Anyways, all right, so I went back and I listened. I made a little grammatical or little factual error here. I said that 1 mole of nitrogen gas, true, but then I said reacts with 2 moles of hydrogen. Obviously, that's a 3. That's not a 2. So I was just supposed to say 3, and then it does create 2 moles of ammonia. All right, let's see if this drawing tool is going to work. If you push the little button, it goes haywire. All right, come on, move my cursor. All right, I guess I'm gonna have to use my mouse. All right, so first we gotta balance this. So we got 2 oxygens here. We only got 1 over here. That's not balanced. So to balance, to get 2 oxygens here, I'm gonna have to go 2 magnesium oxides, arrow, yield sign. We're still gonna have our O2. So our oxygens are now balanced. But now since we got the 2 here, we now have 2 magnesiums. We need 2 magnesiums over here. Very hard to write with the mouse. Let's see if I'm not going to use my drawing tool yet. All right, so now our mole ratio, 2 moles of magnesium is going to make 2 moles of magnesium oxide. That's easy. It's 2 to 2. It's like 1 to 1. All right, so let's see if my drawing tool decides to work again. All right, so here we go. I go over here. There we go. All right. So we got 24.3 grams of magnesium, and we got to first convert that to moles. So line times line. We've done this before. All right. So we want moles. We got grams already. We want to know how many moles this is. So we want moles. Mole goes on top. 1 mole. And 1 mole of magnesium. Oh, how did I not do this? I got to start all over. Give me a second. I got to look up what magnesium's atomic mass is. Give me a second. All right, so now I got it written down up there on the top. You can see, where's my drawing tools little cursor at? There it is. Oh, I need drawing. All right, so we got magnesium. 1 mole is 24.3 grams. And magnesium oxide. Why won't my drawing tool go to the right? I guess I got to use my mouse. Magnesium oxide is 40.3 grams per mole. Let's see if I can get this drawing tool to work. There we go. All right, so 1 mole of magnesium is 24.3 grams. And look what it's given us. It's given us 24.3 grams. So that's not hard to figure out how many moles that is. 24.3 times 1 is going to be 24.3. 24.3 divided by 24.3 is 1. So obviously, we got 1 mole of magnesium here because 24.3 grams is 1 mole. Now, this mole ratio is really easy. You can look on the right. 2 moles of magnesium will react to give you 2 moles of magnesium oxide. So the ratio is 2 over 2. And we want MgO, so it doesn't really matter because they're both 2. Magnesium oxide will go on top. We're getting rid of magnesium, so we put it on the bottom. And now all we do is just got to convert it back to grams. So we want grams, so we put 1 mole on the bottom. And now what is 1 mole of magnesium oxide? It's 40.3 grams per mole. So right there, that should get it for us, the answer. So it's going to be 24.3 times 1 times 2 times 40.3 divided by this on the bottom. So let's see what we get. So 24.3 times 1 is 24.3. 24.3 times 2 times 40.3 equals, go ahead and write this. My thing's going to work. I get 1,950. Oh no, here we go. I touched the button. Gosh dang it. I erase it. Let me try my mouse. All right, so you get 1,958. And I'm going to round it off. Well, I'm going to go 0.6. That goes on top. I can't use my drawing tool because if you push the button, it goes haywire. On the bottom, we got 24.3 times 2 times 1. So it's basically just 24.3 times 2. 24.3 times 2 equals 48.6. 48.6. And now if we do that, 1,958.6 divided by 48.6, let's see what we get. 1,958.6 divided by 48.6 equals 40.3 grams of magnesium oxide. All right, there's another one. I'm going to try to get this drawing tool figured out. All right, one more. Here we go. So there's my drawing tool. Oh, I got it on text. Hold on, let me use my mouse. Drawing tool. I got to hold this pin exactly perfect. All right, here we go. So first I got to balance this equation. Oh, my thing's not working so good. All right, so we got 2 aluminums on the right, 3 oxygens on the right, 2 oxygens on the left, only 1 aluminum on the right. So I'm going to start with oxygen. I'm going to balance oxygen first. So whenever I see 3 and 2, our common number is 6. So I'm going to put a 2 in front of this. Is it going to work? 2 Al2O3. So now 2 times 3 will give me 6. Here's the arrow or the yield sign. And in front of the O2, I'm going to put 3 because then 3 times 2 will give me 6. Now my oxygens are good. I got 6 oxygens. 2 times 3 is 6 oxygens. But now I got 2 times 2 is 4 aluminum. So to balance it out, I can't have 1 aluminum over here. I got to have 4 aluminums, Al. All right, now all the way back over here, let's switch it to black. All right, so we got our info here. The molar mass of aluminum oxide is 101.96 grams per mole, and the molar mass of aluminum is 26.98 grams per mole. There was a typo. I don't know what water came from, so I switched that to aluminum oxide because there is no water in our chemical formula over here. All right, so like always, we're going to start out with line times line, and we're going to switch from grams to moles. So what is it giving us here? It's giving us 18 grams of aluminum. So I want moles. So 1 mole goes on top because that's what I want. And 1 mole of aluminum weighs 26.98 grams. So that goes on the bottom. We want to get rid of grams, so that unit goes on the bottom, 26.98 grams. And it's giving us 18 grams. So that goes right over here. 18 grams of aluminum. All right, when you do this, you can see 18 is less than 26.98. So this can be less than 1. This is less than 1. It's point something moles, like point, I don't know, 7 or something. But if we do that, will give us how many moles. But if we just keep going, we can do it all at once. And if sometime you want me to show you how to do it step by step, I can. All right, so now we're going to do the mole ratio. So it's aluminum oxide to aluminum, and you can see the ratio is 2 to 4 or 4 to 2, but which one goes on top? So that's what we got to figure out. The one we want to get rid of will go on the bottom. We've already got aluminum. We got grams of aluminum here. This is what 1 mole of aluminum is here. So we want to get rid of aluminum. So aluminum and its 4 goes on the bottom. 4Al will go on the bottom. And aluminum oxide and its number 2 in the front will go on the top. So 2, it's going to be hard to write all this, Al2O3. All right, so when we do that, that's going to give us how many moles of aluminum oxide. And now our last step, we just got to convert moles back into grams. So moles back into grams. So I don't want moles. So I put 1 mole on the bottom. We've done this 1,000 times. And aluminum oxide, 1 mole is 101.96 grams. 101.96 grams. So you can see it's always the same little format. All right, so now let me get rid of this drawing tool before I screw it up. And now it's just multiply everything on the top. 18 times 1 is 18. Clear, clear, clear. Times 2 is 36 times 101.96. I have no idea. So, all right, so 18 times 2 is 36. 36 times 101.96. 101.96 equals, I got 3,670.6. So I rounded it off to the 10th place. Divided by 26.98 times 4. That's it. Because then times 1 doesn't do anything. 26.98 times 4. 26.98 times 4 equals, I get 107.92. 107.92. All right, so then I do this math right here in my calculator. 3,670.6, 3,670.6 divided by 107.92, 107.92. And if I didn't make any mistakes, we should get 34 grams. Should have just put G. 34 grams of aluminum oxide, Al2O3. All right, there you have it. So if you need help, come on in at lunch and we'll do more and more and more of these practice problems. It just takes practice and you get the hang of it eventually. All right, so hope you enjoyed it and I'll see you next time.